continue the chapter 8, the memory management. Before that, today I'd like to have only 30-minute lecture because I have a meeting with the president, so which I cannot change it. Meanwhile, after my lecture, the GA will brief about your project, which is extended to the next week. Those who are struggling to complete your project, so he will explain about how to do your project. It's project 1, which is due by the April 1st. Then after presentation, you will have a chance to check your midterm exam sheet. Okay, so please do not leave after the lecture, so until you check the midterm. This is the only time to check your midterm exam. Those who took the makeup exam, it's not graded yet, so two students can check the exam sheet in my office. Okay, so we are talking about the memory management. It's the main memory management. So last time we have seen what is the strategy of the memory management, and we have seen the very basic memory management method, which is a contiguous allocation, which was used for the very old style operating system, such as DOS, which means one or the several processes, but they loaded into the memory as it is, as a chunk. So that caused the problem of the fragmentation that we discussed. As we have seen before, there are two types of the fragmentation. Contiguous allocation actually caused the problem of the external fragmentation. Like to think about I'm not sure whether you have used the Windows 95 or old version of the Windows. From time to time, you need to do the defragmentation of your file system. So then the top of the bar chart, then your file is fragmented, scattered. So they try to compact the scattered file. So that is a defragmentation to address the problem of the external fragmentation. Not only external fragmentation, there is also the internal fragmentation. It looks like very weird. Okay. I'm not very sensitive with such a thing, but as getting old, it looks like weird. So anyway, so internal fragmentation, we will see today after we learn about the paging. Okay, so there are two types of the fragmentation. So we are going to focus on how to address the external fragmentation first, and sometimes we can ignore the internal fragmentation. So first, the traditional way of addressing such external fragmentation is a compactation. How to compact? You can delete and insert it again. So you can swap out and swap in again. That is the compactation. Main problem of such a compactation or defragmentation is the I/O. It requires a lot of I/O. Anyway, you need to remove and load it again. So it costs a lot of I/O. So it's not the practical solution, but it was used, believe it or not, like the old side, in the file system fragmentation, it has been used. There's another way to address the problem of the fragmentation or contiguous allocation. In the contiguous allocation, we load entire process into the memory, as long as there exists enough size of the free space. Okay. The problem of the fragmentation is sometimes too big. So why don't we the chunk, the entire process? At that time, we are going to consider the meaning or the semantic of the program. As you know, program actually is the sequence of the instruction. However, as you know, the program languages, such as object-oriented, the program languages, they can be segmented by the object. Okay, certain object, or function, or module. So we can decompose such a one program as the main program, certain procedure, or function, or method, or object. sometimes local variable or global variable. And they have something group of instruction that has the same meaning, same functionality. So instead of loading entire the chunk of process into the memory, why don't we segment a program by the meaning, okay, or semantic of the routine or the process that each segment by segment we are going to load whenever this function is called. Not at one time, not the beginning of the execution time, but in case this function is called, then entire function will be loaded into the memory. Then what's the benefit? We don't need a big chunk of the memory. Instead, as long as we have the enough size of the free space for this module, which is relatively smaller than the entire program. So we can utilize a small size of the memory, then we can reduce the external fragmentation. So this approach is called the segmentation. So like this one, so this is the program. So instead of the entire program, we can consider group by group, the module by module or group by group of the program, segmentation. Okay, so that each segment will be loaded into the memory. They don't have to continuous. Okay, so that's the idea of the segmentation. So we have learned we can use a very simple idea, contiguous allocation. But here is a segmentation allocation, which is much smaller than the entire program. That we can reduce the external fragmentation problem. In case of the contiguous allocation, we need to manage what? Base and limit. So using base and limit, the contiguous allocation, we don't know where it will be loaded. So we, operating system, should know the location of the program in the memory address and also size of it to protect it. Okay, so we manage the two address, base and the limit in the register. Then using base and register with the operating system locate the specific the address of the instruction. However, here they are not contiguous. It's a segment by segment. So we need manage address of each segment. So using segment table. So instead of the memory management unit, MMU, we are going to manage the segment table. Segment table basic idea is the same. It's about each segment basic address. Okay, each segment their size limit. Okay, so it's called the segment based register, STBR, and segment table length register. It's a limit size of the segment. So there are two more the register. Do the old CPU have the such a thing? No. Some specific CPU manage such a thing if they adopt this segmentation based memory allocation. So it's STBR and STLR are in the registers. Okay, using this one, so we can, so this is the implementation of the segmentation based memory allocation in terms of hardware. So from the CPU to this is S is the segment number. So each segment has each program has so for example this is 1, 2, 3, 4. So each the segment has their number, and this number, using this number we can take a look at. Okay, look at the segment table. There each segment limit and base address. Okay. So the only difference between the contiguous and segment-based allocation is the contiguous entire program. Segment is a segment by segment. So using limit and base, this is the same mechanism of the hardware implementation in the contiguous allocation. So in case the address is less than the limit, it's a thread error, and below that the base the limit is bigger than the so if the address is the higher than limit is out of the boundary, that's the thread. Also, if yes, then we can add the base. Then finally, the locate the physical memory. So that is the segmentation-based memory allocation. This is an example of the such a segmentation-based memory allocation. This is one program. Consists of subroutine, stack, and symbol name, and this is a function. This is just nothing but function name. So let's say we have the 5 segmentation. So we have the number 0 to 4 is a 5 segmentation number. Then each of them has a limit and base. For example, 0 subroutine is size is 1,000 byte. Okay. Then their base location is 1,400. So 1,400 through the 2,400 is the segmented 0. Then we can access the map. The instruction belongs to this segment using this one. Then how can we determine the segment? So for the segment, we can use such a function or object, and also we can consider stack area. Okay, heap area of the process. Do you remember the processor? The data structure processor has a heap and the stack. Stack is used for temporary space, and the heap is used for any dynamic or located. So this is the different module, so we can consider the different segment. Okay? So first we have learned the contiguous allocation, entire process. Next is a segmentation to reduce the external fragmentation. So we have divided one program into several segments. Then each segment will be located by the base and limit. The third one is based on the paging. Still, the segmentation-based memory allocation causes the external fragmentation, as you can see here. What if this is too small to keep any of the segment? We cannot use that, even though we have enough. Total free space is bigger than the certain segment, but if they are fragmented, we cannot use it. That is still external segmentation problem. So to address this one, the current operating system used is paging, not like the pager. Have you ever used the pager? Oh, really? Did you use?
My father used.
So when I think the pager was released in the market 1990, around the 1989. So 1990, I used I had my own pager first time, but anyway, that's different thing. So paging is the what? In operating system, it's a fixed size. It's kind of block, but block is used for file system. So if you took the database course, so we count number of I/O. Number of I/O is based on the database block. It's a for file system I/O unit. Same thing in the memory. Memory, we have the fixed size of the data structure. This will be used for the I/O unit. It's the same idea, but paging is used for the memory. So we are going to use such a pages for the memory management unit. It should be large or it should be small. So relatively small, the data structure. Mostly it's a 512 byte. Okay? Why? Because, do you remember? No, we are going to discuss later. So operating system has the operating system use the I/O unit as the 512 byte mostly. It's called the OS block size. So to synchronize that size, the memory, the page used also 512 byte. However, it can be the power of the two, like the sum of the operating system can be the several megabyte, 4 megabyte, or the 8 megabyte, the 16 megabyte. But most of the operating system use the 512 byte fixed size. So idea is simple. So this is the logical program. Okay, our program, A.out. And this is the physical, the memory. So we are going to divide. We are going to divide the first memory by the page size, 512 byte, 512 byte. So as we have discussed before, memory is nothing but the address. It's a sequence of our address. So we are going to divide group by the 512 byte, 512 byte. Okay, so 0, 1, 2, 3, and number of. This is called page frame. Okay, so we have a number of page frame in the memory. Then, when we load the program into the memory, we are going to segment the logical program, your program, by the same size of the unit. So 512 byte, 512 byte, 512 byte, 512 byte. This is called pages. So we have a number of pages, 0, 1, 2, 3, the pages. Then page by page we can upload. The idea is simple. So do we need all the instruction at one time? Do you need to use are you using all the instruction in your program? Mostly not. Think about your Microsoft Word or PowerPoint, any other program. How many functionality are you using? Only less than 10%. Sometimes it's just you are using basic. Most of the people are using very basic functionality, which means we don't have to load the entire program into the memory. Instead, only whenever the function or the instruction are needed, we can load it into the memory at the time, the page by page. So starting from the main function or main object in terms of Java. Okay, whenever the certain object is called, so the page that belongs to the object will be loaded into the memory. So instead of the memory management unit that has logical address or physical address, we need to page by page mapping table. Okay, so for example, the page number 0, 1, 2, 3. So this is a page frame number. So for example, 0 is loaded into the 3. This one, then number 3. Then the page number 1 is loaded into the page frame number 0. This one loaded into the 5. This one is loaded into the 10. Like that. So whenever you access the instruction from the memory, you are going to check this page table. Okay. Then check what is the page frame number. If you know the page frame number, how can you find the physical address? Multiply by page size 512 byte. 0 times, for example, for example, here the address is the 10. Okay, 10 byte offset from the beginning of this one is a 10 byte. I would like to access the associated address of the 10, the instruction. The instruction is located in this. Okay, then first, what is the page number of this one? Is a 0. So going to the page mapping table, it's a 0 is mapped to the 3. So 3 is over here. So from the beginning of the page number 3 is a 10. Is the instruction that you want, like the move. Okay. At the time, how do you calculate this address? So this is the page frame number 3 times page size 512 byte plus is the address is a 10. So 1536 plus 10, that is 46. So you can find the location. It's a simple math. So it's very quickly done. It will be calculated by the CPU processor, so you can find it. So benefit, as long as you have the free page frame, you can load it into the memory. Okay? You don't have to worry about which one is the biggest chunk, which one is the smallest chunk. It doesn't matter because they are fixed size. Okay? As long as you can find this is occupied, occupied. This is free, occupied, occupied. This is free. So as long as you can find the free space, you can load it into the memory, then update your page table. Okay. So can we address the problem of the external fragmentation? Yes, we can do that. What if all of them are used, but I need to load another pages? How can you?
Write it to the file system. Maybe write it to the file system.
Writing to the file system for what? One of them. Okay. So we need to find victim page. Anyway, so all of them are occupied. There is no space on the memory. So we need to decide one of them as the victim and free. Then this one should be. Do you remember the swap in and out? So swapping is for entire program. So, however, entire program, the swapping require a lot of I/O. So we need to page by page swap in and out. That is called page in, page out. So we can page out. That's the one of the important thing. How can we decide the victim page? Okay? You can imagine. First thing first, yes, we can start from such a basic algorithm. We will see in the next chapter how to decide such a victim page later. Okay, so assume that we have such an algorithm. So this is a victim page and page out. Then this one will be the page in. So this is a page in and out. When you see any monitoring program, so they show how many number of page in and how many page out, number of page out. In addition to that, there is one more. Sometimes this is the kind of a shared library. Okay, shared library. So they are already located in the memory. Then I'd like to access this program dynamically, the link to this one. So page number 4. Page number 4 is page number 3. 0, 1, 2, 3. 3 is in the 10, this one. Okay? If you can find such a dynamically link the page from the memory, you don't have to page in again. You can reuse it, right? It's kind of cache. So at that time you can read it. It's very fast. However, if you cannot find this one in the memory, you need to bring in page in. Such that whenever you fail to read or access the page from the memory, but it's not there, you need to do a page in. That is called page the fault. So page fault is when you cannot find the page from the memory. So you need to do the page in. This is called the page fault. Which one is the most important to be taken care? Page in, page out, page fault. Page fault. Because if you do not have any page fault, that means always you can access the data from memory. So it's a better performance. If you have a lot of page fault, your system needs in and out a lot. So your performance will be degraded. So first, when you check it's the same thing for your Windows system. Going to the task manager, you can see how many page faults. Sometimes name is different, but you can realize which one is which. Then see, if you have a lot of page fault, that means your system has something problem on this page. So that is the pages. Okay. Any question? Okay. So this is a pages. So page, don't be confused. The page is your logical program, your program. So your program architecture and the memory architecture, they are the same, the data structure. So page by page in and out, that is the idea. It's a small size. So page frame is a fixed size block in the memory, so we try to identify such a thing. So this is the example of the paging. We have seen there the logical memory and the physical memory. Okay. Okay, so this is the last slide, I think. So then, paging. So next class in the next week, so we will continue from here. I think that it doesn't take a long time because I already explained about the paging. Okay, so the Jay will introduce about your project 1, which is extended to the next week, and followed by the midterm exam sheet checking time. So please do not leave. And do you have something?
About your project 1, the CPU schedule. In this project, you need to implement a framework for CPU scheduling for 3 algorithms. If first in, first out, round robin, and show this remaining job first. The jobs will arrive at the CPU scheduler at any time. It ranges from the 1 to 20 and at least 15 jobs. And when a job arrives, you know the competition time. And in this project, you don't need to consider about I/O or anyone else. So here is the 3 algorithms. First in, first out. Nothing special. All you need is a queue. And the round robin, you pick up the first job of the queue, round it in the time counter, and preempt, put it in the end of the queue, and put the next one. And anytime a new job arrives, put the new job into the end of the queue. And show this remaining job first. Run the shortest job at the queue. And every time a new job arrives, you need to compare the 2 of them. And if the new job is shorter, switch. And here is the format of the command line. That is the name of your function. -B is mean show the details. And RSF is the round robin, show this job, remaining job first, and first in, first out. And -F is mean read input file. And R is mean random. Your job will create a random jobs by N. Here is the sample of the input file, ID, arrive time, and computation time. Here is a command for spirit. And that is some examples of the output. And that is the output with the -B in details. So you need to show any details, like the change time. And that's for the random jobs. You need to show the jobs like the input file. And there's some main points. The first, you need to analyze the command line and the input and read jobs. And second, you need to create the jobs and the queue. And most important is the algorithm, of course. Here is my idea about the job and the queue. I use a single link for the queue, and each node is a job. You don't need to follow me, you can create by yourself. And here is some limitation. In this project, you can use any programming language. And GUI or command line interface, both of them are allowed. And this project is individual. I know the sheet said this is a group work, but professor changed this, so now that is an individual project. And the due date, you know it, next Friday, April 1st. That's it. So, yes. Sorry, I can.